So let's talk about the accessory organs here, and let's talk about the hair and the nail. And so we'll start with hair and hair follicles themselves. So hair itself can be found in nearly all regions of the skin. It's not going to be found on the palmar surface of the hand or the plantar surface of the foot, but everywhere else in the body we will see hair. Individual hairs develop from cells based within the hair follicle, which is inside of an invagination of epidermal tissue into the dermis, and we'll see a schematic of here in a second here. New cells form and they propel themselves superficially, and the older cells, as they're propelled superficially, become keratinized, very similar to what we saw with the epidermis. The pigmentation that we see here from the hair is due to melanin, just like what we saw with the pigmentation in the epidermis, except for redheaded people, in which the pigment is trichosiderne. And trichosiderne is a different protein arrangement of the same protein melanin. All it's a slightly different fold within the protein, and that's the difference between the brownish pigment and the reddish pigment. And the amount of melanin that's being produced is going to dictate not only the skin pigmentation color, but it will also produce the difference of hair coloration. Now, there is a change in hair coloration with age, and that's where we start seeing the grain of hair. And the grain of hair is due to ROS and superoxide accumulation within the cuticle of the hair due to removal at the sebaceous glands. And so let's take a look at how hair follicles come about. And so hair follicles are going to come about through an invagination process that takes place within the hair itself. And this invagination process leads to the development of a pit, and this pit continues to grow into the dermis, and this pit stops, and it forms the hair root, and from the hair root we're going to get the cuticle to grow. It's going to grow up and through another set of epithelial cells, which will be the sebaceous glands. The sebaceous gland is going to ensure that the cuticle of the hair stays intact. As long as the cuticle of the hair stays intact, the hair will continue as a single unit. Now, what's interesting in terms of the hair itself is that it's actually a spiraling of the tissue that we see, and the amount of spiraling that we see is based off of the amount of thiel bonding that takes place. And the amount of thiel bonding is going to dictate whether or not we have a straight hair, a wavy hair, or a curly hair. It's also going to dictate the quote-unquote thickness of the hair. And thiel bonds are hydrogen-hydrogen bonds, so they're a hydrogen bond that can lead to the amount of tension within the hair and causing the hair to spiral down around itself. Attached to all hair follicles is a specialized muscle known as the erector pili muscle. It's what's being pointed to here in the picture. The erector pili muscle itself is a specialized bit of skeletal muscle that attaches to the dermal ridge and to the hair follicle itself. And what ends up happening is that when it gets stimulated by the autonomic nervous system, it contracts. And when it contracts, what it does is it pulls down onto the dermal papillae. And as it pulls down on the dermal papillae, it increases the tautness of the skin. And as it increases the tautness of the skin, what ends up happening is the hair changes its angle to the skin. And that change of angle leads to what's referred to as an insulation zone. What it does is it creates a barrier around the skin where we start getting warm air being circulated around cold air in between the hair and the skin. And what it does is it basically warms up all of the area, so the area of air around the skin becomes the same temperature as the rest of the body. It's the same effect that wearing sweaters or long sleeve shirts happen to be when you happen to be having a cooler day. So let's take a look at the hair follicle itself and the hair itself. And so what we have is we have distinct areas of the hair follicle. We have the matrix. The matrix is the area of rapidly dividing cells. It's going to propel itself superficially and form into what's referred to as the root. The root has two distinct forms to it. It has what's referred to as the internal and external sheath. The root itself is any of the hair that is not visible or hair proper. The internal sheath is going to be the cells that are lining the cuticle, and the external sheath is going to be the hair that's going to interact with the sebaceous glands. As long as we can keep the cuticle intact, the hair itself will stay intact. When the cuticle gets disrupted, we get a fraying of the spiraling, and that is what leads to what cosmetically refers as the split end. The hair proper is what we see in terms of hair. It's made up of the cuticle, the outer edge of the hair, the cortex, the middle edge of the hair that's being propelled superficially by the matrix and the root, and then the medulla, which is the internal layering of cells, which is keratinizing and moving outward towards the cuticle. So if we look at this in terms of a pictorial representation, notice we have the matrix within the root being actively dividing and propelling itself superficially. As it starts to propel itself superficially, we start getting the development of the sheath, the internal sheath and the external sheath. The external sheath will be bathed by sebaceous secretions as it passes through. That is going to create a hydrophobic region around the hair. And this hydrophobic region around the hair protects the cuticle, the cortex, and the medulla from the external environment. The more often the hair is wetted and washed, the thinner the waxing on the cuticle happens to be. And as that waxing becomes thinner, the hair itself becomes damaged. The hair itself is constantly undergoing regeneration as long as the matrix stays intact. The matrix itself is sensitive to testosterone and excessive amounts of testosterone, in particular the active form of 5-DHT. And with excessive amounts of testosterone, the matrix itself starts to thin out and slowly stop dividing, and it leads to what's referred to as thinning of the hair and can eventually lead to loss of hair, which is one of the things that is seen within males with male pattern baldness. In terms of the functionality of the hair, the function of the hair is to form an insulation around the epidermis. It will provide protection against dust and debris around the mucous membranes and around openings of the body. It's going to protect against friction. It creates a barrier that increases the distance at which friction energy has to travel before it causes damage to the epidermis. And it can be used in mating behaviors. It's the preening and the primping that we will do in order to attract a mate. It's also the behaviors of picking on hairs that we may see in between kins as well as in between partners. In terms of hair growth, we have three distinct growth phases. We have an anagen phase. The anagen phase is growth through the division at the papilla, preparing the hair through the dermis towards the epidermis. We have the catagen. The catagen is where the follicle starts to renew itself, and we start to grow a new shaft that will propel the hair proper out of the hair itself, or out of the follicular pore or follicular opening. And then we have the telogen phase. The telogen phase is the resting phase. This resting phase usually has a dormancy of about 1 month. Now, this doesn't mean that we're not growing. This means that we're not renewing the follicle, which means that we're constantly renewing follicles every month or so, and we're constantly shedding hair. Now, when you have shorter hair, you don't really notice that the hair is being shed. However, as the hair becomes longer, you start to notice that you start seeing the hair being shed. People with more of a tight spiral within the hair will notice more hair being shed during groomings, simply because of what water does to those thiol bonds in terms of causing an increase of helical density, making the hair more dense, making it harder to comb through without damaging the cuticle and leading to the loss of the hair itself. And so that's the hair, and then we'll take a look at nails here in a second.